In this problem where Jacqueline has 6n minus 1 written on the board and she is to represent that pattern, the first thing that I needed to do was I needed to be able to recognize what is the value of each of my terms. So that's where you're going to see my work over here. I've got a value calculated for each of my terms in my pattern. Term 1 has a value of 5, term 2 has a value of 11, term 3, 17, 4, 23, and so on. So the first example I'm going to show you right here is probably like the most basic way that I could represent this pattern. It is baseball season. It should have started and I'm missing it, so I've used baseballs instead of the blocks, toothpicks, or cubes. So you can see that in term 1, I have 5 baseballs. In term 2, I have 11. And in term 3, I have 17 baseballs to represent the terms of the pattern. This would be the more simple way of representing. What I'm going to show you next is how we could use the integer tiles that we used in class for adding and subtracting positive and negative numbers. I'm going to show you how we could use those to represent the variable and the constant in this pattern and still end up with 5, 11, 17, and so on for each of our terms of this pattern. Okay, so here is going to be an example of a more sophisticated method of representing this pattern. So before I explain my use of the integer tiles, I just want to talk about how I got my constant and my variable. So if I were to take my 6n minus 1 algebraic expression and I break that down, the constant is that I am subtracting 1 every time. So I get that from that 6n minus 1. It's the take away 1. That's a constant, and it has to happen every time. The variable is the 6n portion of my algebraic expression, which we know means that I'm just going to add 6 every time I have a new term. So what I've done here is I've represented my terms with images. So this would be term 0, this is term 1, term 2, and term 3. So if we remember from using our integer tiles, our red tiles are our positives and our blue tiles are our negatives. So if I were in term 1 to give myself my constant of take away 1 or negative 1 with my blue and my variable of adding 6 each time, I've got 1 blue tile and I've got 6 red. Now, if I recall from my 0 principle that we did earlier this year, these two tiles cancel each other out, and what I'm left with is a value of 5. In my second term, I have 2 stacks of 6 red tiles because I'm adding 6 twice for the second term. And I've still got my constant of negative 1 with my blue. These cancel each other out, and so then I'm left with 11. And the same thing here. So 3 stacks in my third term of red. The red and the blue cancel each other out, which leaves me with 17. And of course, and then I just added the 0 in as well, just so that I understood, like the constant stays the same every time. So if I was actually to calculate what term 0's value would be in this particular algebraic expression, my term 0 would have a value of negative 1.